All right, so that was, I think, some of the intuition we have in like CNNs to try to understand what's really happening. Before moving on to the next segment, do we have any questions?
Can I ask one question? Can we use multi-kernels at the same time on an image using convolution?
Yeah, I think this. Let me check that. Okay, try now.
Okay, sorry. I was just asking that can we use multiple kernels and just apply them at the same time on an image using convolutional
No, sorry, I
convolution?
can't. Just give me a minute. Let me try to figure out what's going on. I have my headphones, but it's working. I don't know why I can't hear you. Yeah, can you try now, Taylor?
Can you hear me now?
Yes, yeah. Sorry about that.
No,
Go
no.
ahead.
I was just asking that can we use multiple kernels and just apply them on an image at the same time for
What
convolutional filtering?
what do you mean by at the same time?
For
That can have
example,
multiple meanings.
we just looking for finding diagonal relationship
Hmm.
inside of our image. Also, we are just wanted to see if we had vertical lines on it as well. So we just add the columns of ones and diagonals of ones at the same time inside of our matrix, and then start to do convolution over the image uh, to map them to map the features. So would it be possible or just cause an issue if we just do it overlapping?
Yeah, I think I understand where you are going, and that this has to do something with like the associative property of convolution, right? But before going in that direction, so one thing is if you have like let's say the diagonal and the vertical separate kernels, of course you can do that. And then for both the kernels, you will get like separate activation map, and each of them telling you like whether you have vertical edges or not, the other one telling you whether diagonal edges or not. Okay, so that part I think is clear. Now,
Yep.
what you're trying to say is, can we form like a single filter which has both the patterns, diagonal as well as vertical, and
Yes.
then just use that for filtering?
Yes.
So theoretically, I will say yes, because we have seen like the convolution operation is associative, right? But then since we are using these discrete kernels, right? So that's a approximation of the actual convolution. So it won't be the same thing. And if you think about this, let me share my screen. Okay, I hope the whiteboard is visible to you guys.
Yeah, we can see it.
So let's say this will be your vertical kernel and this will be your diagonal kernel, right?
Yep.
And ideally, what you can do is if you convolve these two, then you might get something like this, right?
Yes.
So then it can do at the same time. And theoretically, yes, if it's continuous function, it would have been perfect. But discrete, I think it won't be the same thing, but still you will be able to do it. But then the question is, it's it's then not looking at like vertical edges and diagonal edges, right? It's looking at this kind of pattern because the output is going to be just a single channel, and it will just say that if you have this kind of pattern, it will be active, and for this kind of pattern, it will be like partially active because then you're not matching these two. right? And again, for this kind of pattern, it will be partially active because you are missing these patterns. And that's happening because it's kind of a discrete kernel.
So it's actually not going to help any with any computational complexities if we just mix two filters together. It will just
Yeah, it
going
will
to
be
find
just
something
half,
else.
right? Yeah, it's reducing your computational cost because like now instead of two kernels, you're just using one, right? So in that term, it's helping, but I'm not sure how useful that will be like in terms of extracting features if you want to decompose like these two types of features.
Thank you.
Okay. But yeah, I think that's a very good question. Thank you for that question. All right, any other question we have before we move forward? And please confirm if you can see the slides now.
Yes, we can see it, Professor.
Okay, great. Thank you, Harold, for confirming. All right, seems no other questions. So all right, so any questions before we move on to the next segment?
Professor, I have a question. This might be very trivial, but during average pooling, if there is a decimal, is that rounded off to the ceiling value or the floor value?
If you have a decimal mean, why will you seal or floor it? I mean, we'll just preserve that value, right? Why you want to change the values? We are not changing any values. We are just taking the max of that.
I mean, in average pooling.
In average pooling, I mean, you will just take the average, right? Okay, so these are like just simple examples when I'm showing integers. Of course, in actual neural networks, you will have float values. So you won't have like these integer values there. So whatever float values you will have, you can just compute the average or whatever operation you are doing. Okay, does that answer your question?
Yeah.
Okay, great. Okay, question from Dominic. Could you please explain one more time why pooling causes translation invariance? Sure. Okay, let me do. Okay, you can see my whiteboard, right? Okay, good. So let's say this was your input feature map, and let's say you're trying to find circle using some of a kernel. Again, this is just an example. So in your network, somewhere like in your activation maps, so all these will be like 0. All these will be 0. These are a lot of values. Let's say 4 different values. And in this case, let's say you get a 1 here. Okay. And of course, this is like a very simple shape, but think about like your neural networks, they have like several layers. And by like transforming features from one layer to another, it's not just you're trying to find simple patterns, you're trying to find more complex patterns. All right, so then let's say this is your 1, and if you max pool, your output is going to be 0, 0, because all those were 0 and 1. Okay, so these are your features. Now, let's say you change like the circle to this. Okay, so in this case, what will happen? Again, you will get an activation map, something like all 0, all 0. And then this will be 0, this will be 0, 1, and 1. And this also be 0. Okay, so in your input image, the circle moved, but still it's image of a circle. I mean, the circle is present in the image, right? So your result should not change. Then again, if you perform max pooling, your output is going to be 0, 0, 0, 1. So you can see that even though the circle moved, so there was like slight translation in your input image, your activation map remains the same. Okay? So which means like whatever features your network is trying to extract, it's invariant to that translation. And of course, this is like very simplistic way I'm showing you. It's more complicated than that. But again, this should help you like understand. Okay, great. So that's good. Any other question we have? All right, so if no other question, I think we have a pop quiz today. So I will explain the question here, then I will release it in the web courses, and you will have 1 minute to submit the answer. Let's quickly go over the question first. Let me see if it's there or not. Yeah, it's there. Okay. So the question is, you have your input activation map. The shape is 7 cross 7. And you are going to use a 5 cross 5 filter on this activation map. And you are applying this filter with a stride of 1. And there is no padding. What will be the shape of the output activation map? It says 30 seconds, but you can take 1 minute for that. Okay, so I will just release this on web courses. I think it should be done by now. I think there was a question which I missed. Okay, question from Nayan. Tutorial is for the question answer about the assignments. Yeah, so you can ask like any questions you have, but I think what the TA will do is he will go through the questions and like each step what needs to be done. So he will go like in detail to each of the questions and what are the expectations, what you should be doing. And of course, if you have any questions there, you can ask all the questions. Okay. So let's quickly go over to the solution of this. So if we just like apply that formula, I think which we discussed earlier, the activation map size should be 3 cross 3, but it should be like when you don't need actually the formula for this. If you think about this, if you try to place 5 cross 5 filter here, so this is going to be the first location, right? And that's going to be the second location, and that's going to be the third location. That's it. You can't put it here, you can't put it here. So if you can put just in 3 different locations, that's going to give you a size of 3. And the same will be true for the y-axis because it's symmetrical. And that's why the activation map size will be 3 cross 3. Okay, so question from Sunit. Why does my quiz show as late on web courses even though I submitted 10 seconds after it was released? Yeah, that should not happen because it's like automatically timed. And if that's the issue with like all of you, we know the timing like from this chat, right? We'll take care of that. So Sunit, reach out like after the class, just drop an email, copy the TA, and we can try to resolve this. Okay, question from, okay, it's with everyone. Let me see. Alina, just hold on. I will come to your question. The time limit says 1 minute, so it has to be something with web courses. But anyway, so we know the time when I released, and we know the time like when you had 1 minute, so we'll take into account. So don't worry about it. Okay. Okay, so whoever is having issue with like the late submission, we will take the timings into account. We are recording everything, so okay, so that's good. Now I think there was a question about tutorial Alina. Okay, so I think there will be announcement later today. The TA will make the announcement. Earlier we are going to do it like tomorrow 3 p.m. but I think he will have to change the timing because I think some of you have classes during that time. But whatever time it is, I think the TA is going to make an announcement. Okay, good. So yeah, I think that's correct. It was supposed to be released like in the last lecture. We couldn't do it. Probably that's the issue. But as I said, don't worry about it. We will take your timings into account. Okay, I think I have one more pop quiz for you, and then I think we can end it today. The question is, you have an input feature map. The shape is 112, 112, and the depth is 16. And in this case, we are trying to do a max pooling operation where the kernel size is 3 cross 3. And then you have a stride of 2. So the question is, how many parameters will be required for this max pooling operation? So you will have 1 minute, so don't worry about like 30 seconds, just ignore this. Okay, so I will release this on web courses. This time it's 20 seconds, so you won't have that late issue. You can go ahead and submit.
I don't see the quiz open.
You don't see quiz open. It's released.
Nope.
So probably try to refresh your page.
Yep, it came.
Okay. Yeah, I think your mic is not on mute. You can mute it, please.
Yep, muted.
Okay, so I think we are over time, so that's. So the answer to this question is like you won't require like any parameters because as we discussed, max pooling operation we don't need anything. It's just use the values with whatever you have in your activation feature map, and the operations are usually average pooling. Again, for that you don't need any parameters. Even for max pooling, you don't need any parameters, right? So you just use the mathematical formulas which are required for this. So the answer will be 0 for this pop quiz. Now, any other questions we have? I think we are almost close to 5:45, so I won't continue to the next segment. For the lecture, we can end it here, but I'm here if you have any questions.
I have a question about this last quiz. So the stride doesn't count as a parameter; it's a hyperparameter.
Stride, it's a hyperparameter, right? It's just like you set it to 2. I mean, you're not learning it.
Okay. Oh, I see now. Okay.
Yeah, I mean, it's a hyperparameter, but it's not a parameter. So hyperparameter is something which are like you set based on some heuristics. And usually we have a lot of these hyperparameters when we train our networks. And parameters are something which we learn, which we try to learn using the data. Okay. Similarly, like the shape of the kernel, which is 3×3, it's a hyperparameter. But the actual kernel, whatever value we'll have, that will be the parameters. Okay, question from Dominic. It's because the weights don't update during pooling, right? No, we don't have any weights, right? There are no weights to update. Is it clear, Dominic?
Sorry, it's because the feature maps don't update, or there's no update to the feature maps which have the weights in them.
No, feature maps are not weights, right? Weights are the kernels, the values in the kernels. But in case of max pooling, we don't have any values. So for example, if you go back to, let me go back to this one. Okay. So in this case, let's say this is your activation map. So these are the values, and these values we will obtain based on what was your input image, right? So, and again, these values will change with your input image. Now, this is the max pooling operation. Okay, so, and again, we are using these values, we are obtaining these values as an activation. But to go from this activation map to this activation map, whatever transformation it is, we don't need any weights there, right? For example, in case of convolution, we were doing like the linear combination using the values of the kernels. So the values of the kernels were weights. In this case, we don't have anything. We don't need anything. Is it clear now?
Sorry, is it because we're not getting? I mean, we're getting new feature maps, but we're just downsampling them instead of getting completely new feature maps.
I mean, it's like a new set of feature map, right? But it's based on like your input feature map. I mean, there is some transformation, and that transformation is max pooling, right? But for that transformation, we don't need weights. You can just look at these values and say that, okay, this is the maximum value, which is 6, and just create this feature map. Still not clear?
I kind of get it, but I think there's somewhere that I'm just missing. I'll come to office hours.
Okay, great. Yeah, I think that will be good. All right. So if there is no other question, we can end it here. Thank you all. I will see you next Tuesday.